Hi students, now we are going to discuss something about refractive index of a medium. So far we have solved the numerical problems based on reflection of light by concave mirror and the convex mirror. Now the next topic is based on refraction of light. I have taught you in the regular class. Now you can see here in this picture a ray of light. Say for example this is a AB, okay? AB is a ray of light. It is traveling in one medium and XY is the line of separation of the first medium from another medium 2. So below XY the medium is different, that is medium 2. So that when the light is traveling in one medium enters into another medium, it may bend either towards the normal or away from the normal. So as per this picture I have shown you that the ray BC, the BC, okay, is bending towards the normal. So this bending of light only is called as what? Refraction of light. You must have studied. Okay. So what is this reason for bending also I have taught you in the class. This is because the speed of light in different media will be different. Okay students, the speed or velocity of light is not the same in all media. So whenever the light traveling in one medium enters into another medium, either its speed may increase or decrease, like that you have studied, is it not? Okay. Now whenever the speed changes, its wavelength also will change. This also you must have studied in the theory. When light traveling in one medium enters into another medium, which property changes and which property does not change, I will recall once again. First, immediately the velocity of light will be changing. As a consequence, the wavelength of light also will be changing. But the frequency of light will never change, my dear students. The frequency of light is its intrinsic property, which remains the same. Okay. Now, you can see that AB is the incident ray and BC is the refracted ray. And you can see that the angle made by the incident ray with the normal is called angle of incidence, and the angle made by the refracted ray with the normal is called the angle of refraction. In this picture, I have shown that R is less than the angle of incidence I. That means the second medium is a denser medium, optically denser. Okay, all this you have studied in the theory. Now we are going to solve some numerical problems based on this. Now in all the coming problems, we are going to use the same formula that is called Snell's law of refraction. So the second law of refraction, Snell's law of refraction. So what is the Snell's law? So it is given as a sine of the angle of incidence divided by sine of the angle of refraction is a constant. Okay students, and this constant is denoted by the symbol. This is a constant. It is denoted with the symbol small n for refractive index of the second medium with respect to the first medium. Okay students, so this is equal to refractive index of the second medium divided by refractive index of the first medium. Okay, in some textbooks this is also denoted by the symbol mu. Mu is the symbol. In some competitive exams, if you see that this symbol is also being used, instead of n21, you should read as n21, not n21. Okay students, n21, like that. This is mu 21. So this must be equal to what? Mu 2 divided by mu 1. So this n1 is called the refractive index of the first medium. N2 is called the absolute refractive index of the second medium. So you can see here only one subscript, is it not? N2, N1. So how many subscripts are there? Only one subscript. Whereas here there are two subscripts. Whenever you are having two subscripts, this like N21, N12, that is called by the name relative refractive index. That is refractive index of one medium with respect to the other medium. So N21 is having two subscripts, therefore N21, mu21, these two are called as relative refractive index of one medium with respect to the other medium. Whereas N2 and N1 are having only one subscript. Therefore, it is called absolute refractive index of the given medium. Okay students, suppose if you take N1, okay, N1, So this is called the absolute, okay, this is called the absolute refractive index of the first medium, okay, this is the absolute refractive index of the first medium. But where the light is coming from means automatically the light is traveling from air into the first medium, okay. So like that, N2 if it is specified means automatically light is traveling from air into the first medium, here from air into the second medium. So this is automatically called by what name? It is absolute, okay, refractive index of the second medium. Okay students, so there is only one subscript, then that is called as absolute refractive index of the medium, okay. Also you must know that this is also equal to N2 by N1 also is equal to mu2 by mu1. So this is equal to velocity of light in the first medium divided by velocity of light in the second medium. So N2 by N1 is also equal to V1 by V2, the reverse. So the ratio of the refractive indices is inversely proportional to the ratio of the velocities of light. So N2 by N1 is equal to V1 by V2. This is also equal to nu into lambda 1 divided by nu into lambda 2, where this nu is called the frequency of light. I told you when light is changing the medium, only the wavelength and velocity will change, but the frequency will never change. Therefore, this frequency is not having any subscripts like nu1 and nu2. It is constant. So I can cancel the frequency on both sides. Therefore, I get another equation that N2 by N1 is also equal to V1 by V2. That is also equal to lambda 1 by lambda 2, where lambda 1 and lambda 2 are the wavelength of light in the first medium and the second medium. Okay students. Now, this is N21. N21 is equal to what? N2 divided by N1. Suppose if you want N12, then this is equal to what? N1 divided by N2. Therefore, N21 is also equal to 1 divided by N12. Okay students, so this is called as principle of reversibility of light. Okay students, so these are all the equations which will be helpful in solving the numerical problems starting from 14. Are you ready now? Shall we read the 14th problem? Okay. So what is the speed of light in a medium of refractive index 6 by 5 if its speed in air is 3 into 10 power 8 meter per second? So I will write the given quantities. Velocity of light in air. So this is equal to, I will take this is V1. This is equal to 3 into 10 to the power of 8 meters per second. So what is the speed of light in a medium is asked, no, refractive index is asked. So velocity of light in the medium is asked. So this can be taken as the symbol V2. So V2 must be found. Okay students. Now the refractive index of air with respect to air is equal to 1, and the refractive index of the medium, okay, so this is equal to, see, for air we have used the subscript, no, therefore this is N1 is equal to 1, and here this is Nm is given as what? 6 by 5. So N2 is equal to what? 6 by 5. So first medium is air, second one is the given medium. So that the refractive index of air is 1 and the refractive index of the given medium is 6 by 5. So we are going to use this equation, okay. So N2 by N1 is equal to V1 by V2. So what is asked here? We want V2, is it not? So I will take the ratio. See here, N2 divided by N1 is equal to V1 divided by V2. I want V2, therefore I will take the reciprocal. So what is N1 by N2 is equal to? N1 by N2 is now equal to V2 divided by V1. Okay students. So now what quantity we need is V2. So the velocity of light in the second medium, that is medium, is taken as V2. V2 we have to find out. Therefore V2 is now equal to V1 into N1 divided by N2. So that this is equal to V1 is the velocity of light in air. That is given. So I will substitute instead of V1 3 into 10 to the power of 8 multiplied by N1 by N2. So N1 is equal to 1 into 1 divided by N2 is how much? N2 is given as 6 by 5. So that this is what is 6 divided by 5. So when you take this 6 by 5 in the denominator, 5 will come to the numerator. So this is now equal to 3 into 5 into 10 to the power of 8 divided by 6. So that 3 2s are 6. And 5 by 2 is equal to how much? 2.5 into 10 to the power of 8. Therefore, the velocity of light in the given medium is equal to 2.5 into 10 to the power of 8 meters per second. So, if you do systematically using the formula and substituting them in the steps means you will get the correct answer. I hope you must have understood. Have you understood, students? So, what is the velocity of light in the given medium is 2.5 into 10 power 8. So, from this you must know that inside any medium, light will travel with a velocity less than the velocity of light in air. So in air or free space or vacuum only, light can travel with the maximum velocity. So what is the maximum velocity of light? That is the velocity of light in the air or vacuum. That is 3 into 10 power 8. So in glass, water, turpentine, oil, in diamond, in all these media, light must travel with a velocity less than 3 into 10 power 8. So we are getting less than 3, that is 2.5 into 10 power 8 meters per second. Okay, students? Hi, 15th sum. The speed of light in air is 3 into 10 power 8 meters per second. The medium X, its speed is 2 into 10 power 8 meters per second, and in medium Y, its speed is 2.5 into 10 power 8 meters per second. So we are going to calculate three quantities. The refractive index of the medium X with respect to air. Then the refractive index of the medium Y with respect to air. And the refractive index of the medium Y with respect to X. Now how many subscripts are there in each case? Is 2 subscripts. 2 media. Here medium X and medium air. Here medium Y and medium air. Is it not? Similarly here medium Y and X. That means these symbols are what? Relative refractive index of one medium with respect to the other medium. Okay, students? So now what are all the given quantities? I will note down first. So the given quantities. First one is what? Velocity of light in air. So this is equal to 3 into 10 to the power of 8 meters per second. Then velocity of light in medium X. In medium X, velocity of light is 2 into 10 to the power of 8 meters per second. And the velocity of light in medium Y is given as 2.5. So 2.5 into 10 to the power of 8 meters per second. These are all given now. So first one. So what is to be found here? First one is refractive index of medium X with respect to air. That means this is refractive index of X, Nx divided by refractive index of air. This is also equal to the reciprocal of the velocities. So velocity of light in air divided by velocity of light in the medium X. This is the formula we are supposed to use, students. So that this is now equal to what? Velocity of light in air is how much? This is 3 into 10 to the power of 8 divided by velocity of light inside the medium X is how much? 2 into 10 to the power of 8. So that 10 power 8 is getting cancelled. The remaining is what? 3 by 2. So 3 by 2 is equal to what? 1.5. So this implies, so the refractive index of the medium X with respect to air is equal to 1.5. And it has no unit. It has no unit because velocity divided by velocity has no unit. Okay, students, it is merely a constant, 1.5. So the second one is, now we have to find out what Ny. So Ny with respect to air. You tell me what formula we are supposed to write now. it is Ny divided by Nr, refractive index of the medium Y divided by refractive index of air. This is also equal to velocity of light in air divided by velocity of light in the medium Y. So that this is equal to what? 3 into 10 to the power of 8 meter per second divided by Vy is how much? 2.5. So this is equal to what? 2.5 into 10 to the power of 8. So power get cancelled. This is 3 divided by 2.5. So this is equal to 3 divided by 2.5. This is also equal to 30 divided by 25. So that this is 6 by 5. So 6 by 5 is 1.2. Okay, students. Therefore, what? Refractive index. The refractive index of the medium Y with respect to air is equal to how much? 1.2. So this mathematical calculations and all you can do by yourself. Okay. Now the third one is what is to be found? You see, refractive index of the medium Y with respect to which medium is X. So that this is now equal to what? Refractive index of the medium Y divided by refractive index of the medium X. So that this is equal to velocity of light in the medium X divided by velocity of light in the medium Y. So what is the velocity of light in the medium X? This is 2. So that this is 2 into 10 to the power of 8 divided by 2.5 into 10 to the power of 8. So the power get cancelled, so that this is 2 divided by 2.5 can be written as what? 20 divided by 25. Now it is divisible by 4. Okay, students. So 5 4s are 20, 5 5s are 25. So that this is equal to 0.8. Therefore, so the refractive index of the medium Y with respect to X is equal to 0.8. So this type of questions have been asked many times in NTSC. Understand, students? In competitive exams, this type of questions will be repeatedly asked. Be thorough with them. Are you all thorough? Have you all understood? Okay, fine.